In this video, we're going to be working on real-world applications of parabolic functions, right? That means we're going to be dealing with x squareds, either opening down or opening up. Word problems, essentially, but don't panic. Two basic things is, one, to work along, right? Listen to me, not music, okay? That's the first piece. And at this moment, you probably want to make this video full screen. What's critical is, as we're working along, press pause when needed or when asked, and do work with me or try to get ahead of me by, again, pressing pause if you'd like. And so we have a Portland High School quarterback standing at the 40-yard line at the opponents. So that means he's at this yard line facing this way, or maybe the 40-yard line over here facing that way. So I'm going to be going to the right. And he throws a pass toward the goal, and it follows a parabolic path like that. And the first thing they ask is for us to draw a real-world picture. And this is just to sort of have fun, but to get our head in the game and see what the situation looks like. So the next thing we're going to do is sketch a graph. Now, in order to sketch an accurate graph, we're going to need our vertex. We're going to need our y-intercept. We're going to need our x-intercepts, although we'll probably only use one. Sometimes the -1 isn't appropriate in an application. Now, x is going to be the number of yards from the goal line, and y is going to be the number of meters above the ground. So again, x is in yards, right? So this is a distance. And then height, also a distance over here on the y value, is meters, right? And so we got meters above the ground and yards. So this is yards, and this is in meters. So this is in H, was a capital H. I'll neaten this up. Now, the first thing I decided to work on was to find the vertex. And the first thing I'm going to do is to find the x value of the vertex, which is at the opposite of b all over 2a. So I've gone ahead up here and identified from the function that a is -0.03, b is 1.2, and c is 2. So the opposite of b would be -1.2 all over 2 in parentheses times -0.03, which gets me the value of 20. So that's the x value of my vertex. So we say 20, comma, blank is my vertex. Now, I need the y value. So I find f of 20, which means I put the value of 20 into my x values. So I went into the calculator actually to do this. I didn't actually do all this by hand. I just went in and I went to trace, and I entered the value of 20 in the function, and out popped 14 meters. Or out popped, I should say, 14. And on my graph, it shows that it's right at the vertex. So the powerful piece of using trace is I actually see where it's located in the graph. I know that I'm looking for the vertex, which is the peak of that parabola, because the parabola is opening down, right, like that. So I'm looking for the dot to be blinking right there, which it is. So I feel pretty good that I have done the calculation for the x value correctly, because it landed me at that peak, or seems to be. Next, I want to identify my y-intercept. My y-intercept is the c value, and we're in standard form. Of course, my opposite of b over 2a for the vertex only works in standard form too, so this whole thing is in standard form. My y-intercept is at 0, comma c, which is at 0, 2. So now we have our vertex at 2014, and now we have another point at 0, 2. So we're kind of cooking right along here for vertex and y-intercept. Now, keep in mind that your x-intercept is the value of x when y is 0. So this is when we're going to, quote-unquote, solve the quadratic, right? I'm going to put 0 in for y, and I'm going to solve this. Now, how could I solve it? Well, I could use factoring. That doesn't look very factorable. I could use square roots. Doesn't look like it's able to be done because there's a linear term in there, so that's not going to work. So I guess I'm going to use the quadratic formula. Yes. And again, notice I've left this here. I need to know my values of a, b, and c. Go ahead and process the quadratic formula all the way through. It's okay to use decimals. All right, this is going to work out nice necessarily. You may or may not. If you need to round to the nearest tenth, that's 1 decimal place. Okay, so press pause now, and you go and get the 2x intercepts. There should be 1 negative and 1 positive. Press pause now and work on that. So the two values I get are negative 1.7 and 41.7. So kind of interesting, 41.7, and he's standing on the 40-yard line. Again, these are my x-intercepts, so that would be the coordinates of negative 1.70 and 41.70. So interesting. Looks like he's going to be throwing into the touchdown zone or the end zone. The question is, will the receiver catch it? Okay, to recap what we have so far, we have a vertex at 2014, we have a y-intercept at 0.2, and we have two x-intercepts at negative 1.70 and 41.70. So I think that's enough for us to draw an accurate graph. And so here we go. My x-axis is my distance in yards. My y-axis is height in meters. I put my vertex at the top where it's supposed to be. My y-intercept's right here, my x-intercept's right here. I just draw a casual curve. I label this x-intercept. I label this, well, I didn't really put the 0 there, but we could just put that 4. So that's 0, 2 technically. And notice that I didn't identify this other x-intercept, right? Because that didn't really happen in real life, right? So we're just starting from the y-axis. I guess the initial height that the ball was thrown from, which is 2 meters above the ground, and meters isn't exactly 3 feet, but let's just call it 3 feet. So that's 6 feet. So that sounds about right. You got a tall quarterback releasing the ball at about 6 feet above the ground. So that seems to make sense. 14 meters above the ground. So 14 times 3 goes 42 feet in the air. And it travels 41 yards when it gets to 0 meters or when it hits the ground. Now the question is, did it hit the ground or did somebody catch it at that moment? All right, so now let's go ahead and we can answer the rest of the questions pretty quickly now. So let's go to a question we can answer right away. If nobody catches the ball, approximately where will it hit the ground? That's 41.7 yards on down the field in the end zone. So we're just going to say 41.7 yards down, or it's going to be technically in the end zone. What's the highest point? So we can answer that right off the bat. What's the highest point of the ball? Well, we said the highest point was at the vertex, so that's going to be 14 meters above the ground, right? So remember, x was in yards, y was in meters. But how about this? How high is the ball when it crosses the 10-yard line? So that's right here. That's at x of 10. So really we just need to know is what's f of 10. So we go right into our calculator, and I'm doing this live as I'm talking. I just hit trace 10, and I get a y of 11. So I'm just going to say it's 11 meters high. So where that happens is somewhere, right, at 11 right here. It's going to go up, and then there's another moment where it's at 11 meters high, and we'll discuss how to deal with questions like that on down the road. Okay, we're ready to try another, but this time a little bit faster on my end. All right, remember, you control the speed if you want. Press pause to catch up, and always free to ask questions in class or via email. All right, let's go. So here we have the liters of water remaining in a bathtub. It varies quadratically with the number of minutes, right? So we got volume of water and time. So I think V is the volume of water and T is time. And it looks like this again is in standard form. So label the critical points. Go ahead and find the vertex, the y-intercept, and the x-intercept. Okay, so find these, right? Press pause and go find those. When you unpause, I'll have all of those answers for you, but I'm not going to really go through it as I've done that extensively already. Press Press pause now and you work through. Right? You do the work first, then check your answers against mine. Don't just copy my answers down or you'll still know little to nothing. Just a point to add, the quadratic function here, a, right? A is positive, so that means that this parabola opens up. So it's going to have a minimum, as opposed to the football one, A was negative, so it opened down. So this version looks like this, just for the record. Press pause, do the work. Okay, so this was pretty easy. The vertex, as you see, is at 5, 0, and that's right here. And that's also going to be our x-intercept. The y-intercept is at 0, 60. And again, that's our initial time, right? So time in minutes is our x. So down here, x is our time in minutes. Y is our volume in liters. So at time of 0, we have 60 liters. At time of 5 minutes, we have no liters. And I guess the point of this particular exercise is to realize, like, this is all that happens in real life. Maybe we should get another color, right? This is the real life part, right? From 0 minutes to 5 minutes, we go from 60 liters to no liters. This isn't real life over here. It's just part of the parabola. All right, so now let's go and answer some questions. How much water was in the tub when you pulled the plug, right? That's at time of 0. So I believe there was 60 liters in the tub. That was answerable just by looking at the function itself. When will the tub be empty? Well, that's at 0 liters, right? So at 0 liters, that took 5 minutes. Okay, so there's our 2 answers there. In real world, the number of liters would never be negative, right? So what's the lowest number of liters that the model predicts, right? The lowest amount of liters it predicts is 0. So is this reasonable? And the question is yes. I don't know. Yes, absolutely. Okay, move on. So this next question, like many application questions in algebra, is kind of comical. So it says on a trip you're gonna to the Gateway Arch, you're going to have plenty of time on your hands and you're going to estimate the altitude, something that only Clark W. Griswold does. But what's important to focus on is the x-axis represents the horizontal distance in meters. The y-axis represents the vertical distance in meters. So this is meters and this is meters. Horizontal, vertical. And just to see a little quick picture of the Gateway Arch and some fun facts about it, it says that it is 632 feet or 192 meters. I guess that's the height. It's clad in stainless steel, or it's wrapped in stainless steel. And it's the world's tallest arch, right? Tallest man-made monument in the Western Hemisphere, built as sort of a tip to the westward movement, right? So the gateway to the west. So just a little interesting piece. I think the most important one to me is it was completed on October 28th, 1965. October 28th, 1974 would be when I came into existence. All of this totally useless in terms of solving the application. Let's get back to business. Now, one of the things I noticed is that this is in standard form, but there is no value of c, so that's a +0, which means that right here, the y-intercept is 0, 0. So that's also an x-intercept. So that's an x and a y-intercept all at one time. Our other x-intercept is over here, right? That's the number 2 x-intercept. And the vertex is up here, so that means our A must be L negativo, and it is. All right, so how far apart are the two ends? Well, I guess we're just going to do x sub 2 minus x sub 1, right? The x-intercept number 2 will be a positive number minus x-intercept number 1, which is 0, right? So the x value of 0 and whatever x value this is, the difference of those two numbers will be how far apart those are. So you're going to want to use the quadratic formula to solve for those two and get your answer there, right? How tall is the arch? Well, of course, that's going to be your vertex xy, right? So your vertex is at x comma y, and the y is the vertical distance, right? So how tall is the arch? Well, we kind of gave away the beans, so you should have the work to support it. I will tell you this, I get in the 180s, so that doesn't actually match up with the Wikipedia value. So we're going to go with the value that we get from, the value that we get from our work using this and our formula for the vertex in standard form. So let's see, we've checked off then how to find the distance and how to find the arch, right? So that's going to be the y value of the vertex. And the last one I'm going to work out with you, right? So this is a little bit more of a trickier question. So you have this airplane, and the airplane is going to try to fly through the arch. And the question is, if the wingspan on the plane is 40 meters, so the distance from here to here is 40 meters, and it's going to fly through, right? It's going to fly through at an altitude of 170 meters. Now we know that the height, right, up here, we know that this is, I told you, in the 180s, right? I'm not going to give you the exact number. You should figure that out on your own, but we're going to talk about at 170. So at 170, you're going to have a height over here that corresponds to an x down here. And also, it's going to have a mirror image over here, which corresponds to another x value. And the difference of these two x values is the span of the arch at that moment. And what we're hoping is that that span is bigger than 40 meters. Otherwise, this plane is going to hit the arch, and that won't be good. So let's go ahead and try the math on this one. Okay, so we have our function, and we have a height of 170 meters. So what we're going to do is we're going to replace that height in for y. We know that the height is 170. Now, to use the quadratic formula, we need to set this thing equal to 0. So we're going to subtract 170 from both sides, and we'll get 0 equals this whole thing right here. So now we'll have an a equal to negative 0.0283, a b equal to 4.578, and a c equal to negative 170. And now we're going to use the quadratic formula, and we're going to get two answers. And now both of these answers should be positive because they're in the positive zone. So go ahead, press pause, process the quadratic formula, and get those two values. Press pause now. Do the work yourself. So after a little bit of calculations, I have arrived at, this is sort of a few steps in after I took the square root. I took everything out to the nearest hundredth and got final answers of 5774, which is this spot, and 104.03, which is that spot. And when you take the difference between those, you get approximately 46 meters. Right? So the question goes back up to this. So if you have a plane with a wingspan of 40 meters flying through at 170 meters, could the plane possibly make it? So 46 meters is the reasoning behind my answer of yes, if the pilot is good. Right? There's really not room for error here. So it's kind of a cool question. So this last one is yours for homework, right? You have the Cannonball King back at summer camp, right? We got a negative piece here, so I think we're going to look something like this. You're going to draw a real-world situation. And so you have this guy jumping off of a diving board. So I think if you're going to jump off the diving board is probably going to be above the pool like that, right? So something like a real-world thing like that. But you're going to draw a better version, right? So let's really see your art come into play. And then we're going to get a actual, good quality sketch. We're going to want some y-intercepts, so vertex, x-intercept, and that's going to answer most of your questions. it gets a little critical at the end, and you're just going to have to really think about things. So these questions start to become pretty straightforward. Draw a good graph, labeled how tall is the diving board. Think about what that means with respect to the parabolic function. How high does Carmen jump? After how many seconds is Carmen at the same height as the diving board? So I think, again, here's, I think you're going to look for that height being the same height. So you might have to do something like the 170 in the last question, right? Only using this height and setting it equal to 0 again and finding the 2 moments where they're at that height. And then this last one is going to be a critical question. All right, so use your problem solving skills and really think about it. Just keep in mind that time is your x value and height is your y value. So when you see things like 7 seconds, apparently that's a time value, right? That's thinking in terms of x, and you have this 1.4 seconds. So again, kind of try to put things together. Don't be afraid to ask questions. Don't be afraid to try. Good luck, and we'll see you next time.